85. Oh, terlalu jauh. Oh my god. 85. 85. This is 84. Oh, yes, this one. Momentum. Yeah. Yeah, so today, please don't go anywhere. We will discuss about momentum. Yeah, this is actually on AS level materials. Yeah, uh, momentum is, I think you still remember. Yeah, momentum is about multiplication between mass and velocity. Yeah, you say this when two cars, like collision. Yeah, yeah, this is some of the apa namanya, kelanjutan dari momentum, ya, further types or further apply or further case in momentum. Yeah. Okay, maybe a little bit fast. Yeah, this the um, theory, or this the formula of momentum. The momentum is mass time velocity. Yeah. This is the basic one. Yeah. So if we have question like this one. Yeah. Calculate the momentum of each of following object: 0.5 kilogram stone traveling at velocity. Yeah, we just calculation between 0.50 with 20 meter second. Yeah. So this is something momentum 10. Yeah, a half of 20. And then also P is 25,000 kilogram times with 20. Yeah. That's it. And C, maybe the electron mass of 9.1 times 10 to the power negative 31. Yeah, times velocity. Yeah, 2.0 times 10 to the power 7 meter per second. Yeah, it's about momentum. Then, oh, this is about collision. Yeah, two balls, each mass 0.50 kilogram, collide as shown in figure 6.6, so that their total momentum before collision is equal. I think this mass, each mass, I think same thing. Yeah. When we see without write about how to solve this, you see this 0.5 times 2 negative 0.5 times 3, so same thing with negative 0.5. Yeah, equals to 0.5 times 2 plus 0.5 times 1. Yeah, sorry, negative. Yeah, so this is, I think, same thing here. The momentum on the left side is same thing with momentum on the right side. Yes. Then this is also collision. Ya, collision, ya, tabrakan atau tumbukan. Ya, on the tabrakan, collision or tumbukan in bahasa, ya, we know about the types of collision. Ya, the first one is perfectly elastic collision. Ya. Perfectly elastic collision is when the total momentum is same. Yeah, this here. Total momentum for collision. With this is about find the momentum and kinetic energy. This one. Yeah. In the perfectly elastic collision, relative speed of approach equal relative speed of separation. Yeah. Okay, that's it. Then an inelastic collision is when before and after is different. Yeah. So like some of energy is lost, changed into other collision. Yeah. But in fact, momentum is always conserved. Yeah, in all collisions. Okay, maybe a little bit fast, yeah. Actually, we go to the end chapter question, ya. Kita nanti lihat yang end chapter question, kayaknya lebih pas, ya. Then, okay. Maybe we try to solve this question here, number 5 or number 6, yeah. Let me check one by one. Question 5, yeah. Oh, gede banget. Figures 6.11. So to identical ball, yeah. This is identical means the mass is same, yeah. Uh, about to make head-on collision. After the collision, ball A rebounds at speed 1.5 meter second minus 1, and ball B rebounds at speed 2.5 meter second minus 1. Yeah. The mass of each ball is 4.0 kilogram. Yeah. Okay. Uh, okay, we use this figure, yeah. I don't need to write again. Uh, so question A, yeah, calculate the momentum each ball before the collision. Momentum A, yeah, equals to mass time velocity A, yeah. Its mass is same, yeah. This is 4.0 kilogram times velocity A is 2.5, yeah, 2.5 meter second minus 1 on the right side, so this is positive, yeah. So this is something with 10, yeah, point O meter second minus 1 kilogram meter second minus 1, sorry. The unit is in kilogram meter second minus 1, yeah. This is PA, yeah, momentum of A. So continue to find the momentum of B. This is mass B, actually same thing with mass A. So maybe, yeah, I don't need to give the initial B here, yeah. So mass equals 4.0, and then VB, yeah. This is on the left side. V sign negative, yeah, negative 1.5, yeah. So this is something with negative 6, yeah, 6.0 kilogram meter second minus 1, yeah. This. Okay, for question A we get 10 kilogram meter second minus 1 and 6.0 kilogram meter second minus 1 each for ball A and ball B, yeah, initial momentum. Then let's check B question. Calculate the momentum of after collision. After collision, okay. Let's say I use here there. After PA, yeah, after is mass VA after, yeah. Let's say this is 4.0. Now VA, this is here 1.5 rebounds. Yeah, it's mean they back like into the left side. Yeah, so it's mean this is negative 1.5. Yeah, here this one. Yeah, ball A rebounds. Yeah, rebound is mean back to the left side. Yeah, become 1.5 meter second minus 1. Yeah. Okay, so this equals to negative 6 here. Yeah. Kilogram meter negative 6.0 kilogram meter second minus 1. And then PB after collision is mass time VB after collision. This is Bapak aja pakai tanda begitu ya. It's been after ya, after ya. Maybe you different, it's okay. Yeah. So B it's rebounds also, yeah, at the speed 2.5. So rebound it's mean go to the right, yeah. So in the positive side, positive 2.5, yeah. So here is 10, yeah. Point O in kilogram meter second minus 1. So you see this here. I think before we read about the next question, you can see this is about 10 minus 6. This is minus 6. This is 10. So like the same thing between momentum after and momentum before. Yeah. It's a momentum constant to collision. Yes. Yeah. Yes. You see this here. Momentum become to zero total momentum after and before. Yes. Then so that total kinetic energy of two balls is conserved in the collision. Oh, waduh. So kayaknya panjang nih guys. Kinetic energy before ya, a half m va square plus a half m vb square also ya. So this is a half mass is 4.0 and VB is 10 square plus a half, yeah, 4.0 times negative 6, yeah, times square. Yeah. So ini tuh jadi 136 kali 2, 273. This is about 272, yeah, 272 joules. And also same thing on the after. Sorry. Momentum after is same thing also. Yeah. Ya ampun. This is same thing, yeah, same thing before and after. Yeah. Yeah, let's say this is kinetic energy, total kinetic energy on before, yeah. Saya tulis ini before. And this is after, yeah. But I have to change about velocity, yeah. This is after. This velocity is not 10 and minus 6, yeah, but Oh my god, Bapak salah. 10 itu kan momentum ya. Salah salah. Wait. I wrong. Ya Allah. This is about. This is not 10. This is not 6. Sorry. Ini salah. Ini adalah 2.5 ya. 2.5. Ya. This is negative 1.5. So here is 2.5, 6.6 as a 625, 6225, terus 17. This is 17 joules, and here also this is wrong ya, not 10 with negative 6 ya. 10 and negative 6 about momentum. Here is negative 1.5, and this is 2.5. So same thing ya, hanya berubah posisi saja. This is same thing 70 joules ya. So kinetic energy before and after is same ya. 17 joules and 17 joules ya. Okay. Kemudian so the speed pause on the same. Oke, one more maybe ya. Kita selesaikan aja satu number lagi yang I. Ya. Sama nggak velocity-nya? VA plus VB. Ya. This is 2.5 plus negative 1.5 ya. So same thing with 2,5 ya, 1.0 meter second minus 1. This is before, and after is VA after plus VB after. It means negative 1.5 plus 2.5. Same ya, 1.0 meter second minus 1. Yeah. So same thing ya, between before and after. Relative ya, speed the balls on the same before and after collision. Kemudian ada collision in 2 dimension ya, this one ya. This is actually same thing ya. The concept is same when the collision allow for momentum conserve. Yeah. Momentum after equals to momentum before. So like this one, yeah. This is after, red before. Momentum before equals to momentum after. So momentum A, momentum this line yeah, equals to momentum the red line and this line. So when in the component of vector, this is like mv plus mv equals to mv here yeah. This is before yeah, equals to after. After plus after equals to before. So maybe lebih more than understand if we see the case here. Kita lihat mungkin kita cek question 11 and 20 ya. 11 and 20. Nah, kalau cukup kita with 20 ya, kalau enggak ya nggak apa-apa. Okay, we see the question 11. Yeah. Figure 6.18 show the momentum vector for two particles 1 and 2 before and after collision. So the momentum is conserved in this collision. It's particle, yeah, and then like apa namanya pecah ya menjadi dua. 2.4 kilogram meter second minus 1. Yeah. Oh wait. All become two momentum ya. So okay, so that ya, kita suruh nunjukkan momentumnya itu sama ya. This ya on the particle 1 and particle 2 ya. We have like separate momentum on the x and on the y. Yeah. This on the x we have 2.4 cos 60. Yeah. And on the y we have 2.4 sine 60. Yeah. This is also same thing on the x and on the y. Here 2.4 sine 60. Yeah. This also 2.4 cos 60. Actually on the x direction on the x direction momentum before it is momentum before is 2.40 kilogram meter second minus 1, and momentum after is on the x is 2.4 cos 60 plus 2.4 cos 62. Cos 60 is a half. This is also a half. So this is something 1.2 plus 1.2. Same to 2.4 again. 2.4. Okay. Kilogram meter second minus 1. So between them is same. What about on the y direction? Y direction is 0. 0. 2.4 sine 60 negative 2.4 sine 60 become 0. Jadi ini nggak usah kita solve lagi, ini udah saling neglected saling menghilangkan. Okay, that's it. Coba kita lihat number 12. Number 12. A snooker ball collides with a second identical ball as on figure 6.16, 6.19. Determine the component of velocity of the first ball in the x and y direction. Wait. This one so on the x question A, V on the x is V cos 20. Aduh Bapak, sorry agak ngelag ya. So V is 0.80 ya. 0.80 cos 20. It's about 0.75. Yeah, we get 0.75. 0.75, yeah. Meter second minus 1. Yeah. And on the y, yeah, v on the y, yeah, v sine, yeah, 20. 0.80 sine 20. Ini about 0.8 sine 20. 0.27. This is about 0.27, yeah, meter second minus 1. Nah, that's it. Question A. Yeah. And question B, hence determine the components of the velocity of the second ball in the x and in the y direction. Oh my god. Wait. Hmm. The components of the velocity of the second ball on the x and y. Second ball. Dari mana ya? We don't know about velocity on the second ball. Tapi kita punya v vy ya, on the second ball equals to hmm, oh wait, x first ya. Aduh, belum bisa dihapus. Aduh, ngehang lagi. Sorry, ngehang. Vy equals to same thing with this one, 0.27 ya. Meter second minus 1. Why? Because yeah, same yeah, on the x, sorry, on the positive y, yeah, yeah. This is same. Hmm. Vx equals to yeah, u minus the second ball. In this is on the second ball. Yeah. Vx 0.75. Yeah. So this is 1.0 minus 0.75 equals to 0.25. Yeah. Kita hanya mengurangin ya guys ya, subtraction dari u ya, yang nilai 1.00, dan kita memiliki yang Vx on the di sini ya, yang tadi 0.27 ini. So, question C is uh, about velocity second ball is root of 0.27 square plus 0.25 here between velocity on the x and y direction. 0.25 square plus 0.2 square and we root it, yeah, 0.37, yeah, this is about 0.37, yeah, meter second minus 1. Yeah, let me check question about question 13, maybe, yeah, 13, one number again, maybe one number, yeah, this number 13 is car mass 1000 kilogram traveling velocity at 10 meter second minus 1. It accelerates 5 seconds, reaching the velocity to 24 meter second minus 1. Calculate, yeah, change momentum of the car in the 15-second period. Change of momentum is delta P, yeah. Delta P equals to M delta V. Yeah. Uh, they have mass for 1000 kilogram and change in velocity. They have reached velocity from 10 to 24. Yeah, so delta V is 24 minus 10. Yeah, yeah. So this is equals to 14. So jadi 14,000, ya, kilogram, ya, meter second minus 1. Yeah, that's it. Okay, one more question. Yeah, on the B question. The average force acting on the car as it accelerates. Force, yeah, you know that delta P over delta T. Yeah, delta P we have 14,000. Yeah, oh my God. Uh, per delta T is 15. So equals to, oh my God, 933, ya. Angkanya kurang bagus. 933.33, ya, Newton. Okay, this is the answer for force, ya. Let me check in other formula, ya. Kita cek coba di formula yang berbeda, ya. You know, force is mass times velo times acceleration, ya. We check that force equals to mass times acceleration, or mass times acceleration is v minus u divided t, ya. 14,000, so 1,000. 1,000, oh my God, this is 24 minus 10 divided t is 15. I think same thing, yeah, this is 14 divided 15, yeah, same thing, 933 Newton. Same, yeah. Between formula this and this, yeah, become 933 Newton. This is something also 933 Newton. Yeah, that's it.